We think of life on Earth as being pretty fragile. We talk about how delicately balanced our ecosystems are and how human activity is disrupting that balance. But here's something to consider. All life on Earth depends on delicate processes taking place inside of the core of our planet. And it's been that way for billions of years. Take volcanoes, for instance. They can seem like destructive forces of nature that are capable of wiping out whole species. But what if they're also responsible for making life possible in the first place? You see, volcanoes aren't just found on Earth. Scientists have identified volcanoes on Mars, Jupiter's moon Io, Venus, and even Saturn's moon Titan. So while volcanoes might seem like an important part of what makes Earth unique, they're probably a pretty common feature of rocky planets in general. But the thing is, even though scientists know quite a lot about the inner workings of other planets, they don't really know why volcanoes exist on Earth, or where all their energy comes from. It's one of the biggest mysteries surrounding our home planet, and understanding it could tell us why we exist at all. The first hint of this mystery dates back more than a century. In 1859, a scientist named John P. Hopkins noticed that Earth's continents were lined up almost perfectly with the world's active volcanoes. This observation led to the theory that Earth's continents used to be joined together in one supercontinent called Pangaea, and that they split apart due to volcanic activity. But that's not the whole story. Scientists now know that plate tectonics plays a big role in the formation of volcanoes. Most volcanoes occur at the boundaries between Earth's tectonic plates, which are constantly shifting and colliding with each other. When two continental plates collide, one of them usually gets pushed under the other in a process called subduction. As the plate descends into the planet, it melts and creates magma, which then finds its way up toward Earth's surface through cracks and breaks in the crust. That magma eventually solidifies into igneous rock, creating new landmass. But this process doesn't explain where the energy comes from to drive it all. And here's the weird part. Even though scientists have spent decades studying the inside of Earth, they don't actually agree on what's powering these volcanoes. Most theories trace the energy back to heat left over from Earth's formation. This makes sense because Earth formed about 4.5 billion years ago, but scientists can't explain why that heat would come surging up right now after all this time. One idea is that Earth's core has a solid inner part and a liquid outer part. And even though they're both made of iron and nickel, the inner core is actually 600 degrees Celsius hotter than the outer core. Some scientists think there's enough heat in that temperature difference alone to keep driving volcanic activity for billions more years. But if that's true, you'd expect volcanoes to be active all over the planet. But they're not. They tend to follow plate boundaries, not temperature boundaries. It's possible that the heat from Earth's core isn't the only thing fueling volcanoes. Maybe chemical reactions inside Earth are also playing a role. Take oxygen, for example. Most people think of oxygen as a gas, and that's true above ground. But deep inside Earth, oxygen exists in solid form. It's like a brick wall instead of a flowing river. And some scientists think that oxygen could be reacting with metals in the planet's mantle and creating pockets of energy that fuel volcanoes. So how do we figure out which of these ideas is right? Well, it turns out there's an unusual part of Earth that holds clues about what's powering our volcanoes: the deep ocean trench. These trenches are found near the boundaries of tectonic plates that are colliding. And as one plate dives under the other, it carves out a deep trench in the ocean floor. What makes these trenches special is that they preserve the remains of the descending plate before it gets completely destroyed by Earth's intense heat and pressure. Scientists have discovered some surprising things inside these trenches. For example, they found ancient ocean water that's more than 2 billion years old. There shouldn't be any water that old left on Earth. It should have all recycled through the water cycle long ago. And yet somehow, this water managed to survive all that time, presumably because it's been deep inside Earth's mantle. Other scientists have found whole layers of the ocean floor inside these trenches that shouldn't exist. They've found seafloor that's more than 100 kilometers beneath the surface, and they have no idea how it got there. It's as if you looked down a mine shaft and saw the ground from a different continent. And there's more. Some deep ocean trenches contain rocks that are thousands of years younger than the seafloor around them. It's like finding a brand new piece of driftwood in an ancient shipwreck. How can these rocks be so young when everything around them is so old? Scientists think these mysterious rocks may hold the key to solving Earth's volcanic mystery. You see, the age of a rock is determined by radioactive isotopes inside of it. Over time, the isotopes decay into different elements, leaving behind a record of the rock's history. But sometimes the rocks themselves can rewrite that history. Scientists have found deep ocean trench rocks that seem to have reset their internal clocks. Their age is much younger than the actual age of the rocks themselves. And that's happening because of Earth's extreme heat and pressure. Those conditions reset the rock's internal clocks, making them look way younger than they actually are. And that means the seafloor we find in deep ocean trenches may be much older than we think, maybe even as old as Earth itself. This discovery suggests that Earth's mantle may be recycling the same old material over and over again. If that's true, it might mean that Earth's volcanoes are powered by more than just leftover heat from our planet's formation. They could also be powered by the constant recycling of seafloor in our mantle. What's more, this recycled material may contain oxygen that's been locked inside the seafloor for billions of years. And when that oxygen reacts with other compounds in the mantle, could release the energy needed to power volcanoes. This idea makes a lot of sense considering that most volcanoes are found at plate boundaries where seafloor is constantly being recycled. To test this hypothesis, scientists collected samples from deep sea trenches in the eastern Pacific Ocean. They studied the rock's chemical composition and their age to reconstruct the history of our planet's seafloor. Their findings suggest that seafloor recycling actually does play a major role in powering Earth's volcanoes. And that discovery could help scientists better understand how Earth formed and evolved over billions of years. It could also help them predict how volcanic activity will change in the future. And hey, if you ever wondered whether aliens might be using volcanoes as a source of energy, well, now you know that we're all in this together. Even though we still have a lot to learn about the inner workings of our planet, it's clear that volcanoes are an essential part of life on Earth. They may have helped create the continents and oceans that we depend on, and they may continue to shape our planet for billions more years. So the next time you hear about a volcanic eruption, remember that it's not just a destructive force of nature. It's also a reminder of the incredible power that lies beneath our feet. Speaking of incredible forces of nature, you know what else we owe to physics? Our entire modern technological society. Physics helps us understand everything from the smallest atom to the largest star, and we use that knowledge to improve lives here on Earth. That's why Brilliant is so great. They offer interactive courses that teach you real science, stuff that's used in the real world every day. You want to know how cell phone towers work? Boom, done. Want to know how to calculate the stress on a bridge? Boom, done. Want to know how neural networks work? Boom, done. Brilliant's got you covered, and they're adding new courses all the time. Plus, you don't need to be a rocket scientist to enjoy Brilliant. All you need is a computer or smartphone with an internet connection. So if you want to learn more about the universe and how we use physics to understand it,